What of the following could be the highest common factor, the HCF, of 12, 18 and k, where k is an element of the natural number set. So k is a positive whole number. 1, 2, 3, 4, 5. So the HCF, the highest common factor of 12, 18 and k, must be a factor of 12 and 18. Therefore, from 1, 2, 3, 4 or 5, the possible factors are 1, 2 or 3. Because 4 is not a common factor of 12 and 18. It is a factor of 12, but it's not a factor of 18. And 5 is not a factor of either number. So, of the numbers listed, 1, 2, 3, 4, 5, the only possible factors are 1, 2, and 3. Because in order for one of these numbers to be a factor of 12, 18 and k, they must first of all be a factor of 12 and 18. Part 2. If the highest common factor, the HCF, of 12, 18 and k is 3, describe the possible values of k. So what could k be? So we're told that 3 is the HCF of 12, 18 and this unknown value k. So we need to figure out, well, what could k be if 3 is the HCF? So the HCF, the highest common factor of 12 and 18 is 6. So if you were to list the factors of 12, the factor pairs, we have 1 times 12, 2 times 6, 3 times 4. So the factors of 12 are 1, 2, 3, 4, 6, 12. The factor pairs of 18, 1 times 18, 2 times 9, 3 times 6. So the factors are 1, 2, 3, 6, 9 and 18. So clearly the HCF is 6. Now alternatively, you could write out your prime factor trees or your prime factors, just list your prime factors in order to get the HCF. So the HCF of 12 and 18 is indeed 6. Now if the HCF of 12, 18 and k is 3, then k must be a multiple of 3, but not 6. So we want 3, which they're telling us 3 is the HCF, to divide evenly into k. So if it's going to divide evenly into k, then k must be a multiple of 3. So k must be a multiple of 3 in order for 3 to be the HCF of k and some other numbers. But k cannot be 6. It cannot be a multiple of 6. Because if it was, then the HCF of 12, 18 and k would be 6. And we're told in the question that it is not. It is 3. So since 6 is clearly the HCF of 12 and 18, then 6 cannot be a multiple of k, because otherwise the HCF wouldn't be 3. It would be 6. So k could be 3. So 3 is a multiple of 3. So if k was actually 3, then indeed 3 would be the HCF of 12, 18 and k. And you can test that yourself by writing out the factors. It could be 9. So if we have 12, 18 and 9, 3 again would indeed be the HCF. It could be 15. So we could have 12, 18 and 15. If we were to list the multiples of all of those numbers, again 3 would be the HCF. It could be 21. We could have 12, 18 and 21. Again, if you list the factors of 12, 18 and 21, you would see that 3 is the HCF. It would not be 24, however, because 24 is a multiple of 6. So even though 24 is a multiple of 3, it's also a multiple of 6. So 6 wouldn't work, because if it was 24, if we had 12, 18 and 24, then the HCF would be 6. It would not be 3. So you have to be careful with that. So you're actually really working backwards. It's a HCF question, but you're working backwards. So what are the possible values of k? They can be any multiple of 3. For example, 3, 9, 15, 21. But they cannot be a multiple of 6. So I know 6 would go in here. That is a multiple of 3. and 24 would go next. That is a multiple of 3, but they are also multiples of 6, so that would not do.